Welcome to Summarize Science. When AIs allocate limited resources, like drivers in a ride-sharing app or spots in a housing program, they're usually designed to be as efficient as possible. But this focus on efficiency often creates deeply unfair outcomes, where some people get great service and others are left behind. A new research paper introduces a groundbreaking framework called GIFF that aims to fix this without having to rebuild the AI from scratch. GIFF, which stands for General Incentives-Based Framework for Fairness, works by cleverly analyzing the decisions an AI is already considering. It looks at the estimated long-term value of each action, which in AI are known as Q-values, to infer which decisions will lead to fairer results. Here's how it works. For every possible action, GIFF calculates a fairness gain to see how it would affect the overall distribution of resources. But the truly innovative part is a mechanism called advantage correction. This essentially discourages agents who are already well off from taking actions that benefit themselves at the expense of others. It creates an incentive for the haves to leave resources for the have-nots, allowing them to catch up. A central arbitrator then uses these new, fairness-adjusted values to make a final allocation that balances both efficiency and equity. The researchers put GIFF to the test in several demanding, real-world scenarios. In a complex ride-sharing simulation, GIFF was tasked with assigning passengers to drivers. As these graphs show, the framework consistently achieved a better trade-off between fairness for both passengers and drivers and the overall service rate of the system. It successfully outperformed a strong, existing method designed specifically for this task. Next, they applied it to a real-world dataset on homelessness prevention. The goal was to assign households to support services in a way that was fair to all demographic groups. GIFF once again proved highly versatile and effective, dramatically improving fairness across 38 different metrics. Even in cases where it wasn't the single best-performing method, it was always a very close second, demonstrating its robustness and reliability. Finally, in a challenging job allocation game where one agent could easily monopolize a job, GIF's advantage correction was crucial. Without it, the system would result in a completely unfair outcome, but with it, the AI discovered the optimal and far-sighted strategy of equitable turn-taking. This resulted in a solution that was nearly perfect in both total utility and fairness. So, let's recap the important points. The GIFF framework provides a powerful and practical way to integrate fairness into complex AI resource allocation systems. Crucially, it achieves this without requiring any additional, costly retraining of the underlying AI models. Its advantage correction mechanism is key to encouraging cooperative and far-sighted fair behavior. By proving its effectiveness in diverse domains like ride-sharing and social services, this work represents a significant step towards creating AI systems that are not just optimal, but also just. It's a principled way to make our increasingly automated world a fairer place for everyone. Thanks for watching Summarize Science.